So this is week 2 of our introduction to coding electronics with Arduino and Raspberry Pi. So this week we're really going to be focusing on Arduino, but we're setting up the Arduino IDE on a Raspberry Pi computer. So this is like tactile learning. So it's hands-on creativity. It's stuff we can touch, we can plug in, we can play. So Arduino makes learning electronics and coding fun and interactive. Dry coding just for coding's sake is boring. But if you actually realise that this code does something, makes something move, makes something work, you understand where it fits into the real world. It's beginner friendly and it's very, very versatile. So it's got an easy to use interface, a massive community, absolutely countless tutorials. Arduino is perfect for beginners and it still offers possibilities to do real expert things, which we'll discuss a little bit later on. It boosts our problem solving skills and our innovation skills, which is, it's really good to develop your critical thinking, but also like the real good skills for what they call STEM, science, technology, engineering and maths. But I like to put an A in there as well because I do think there's a big part in the arts for this as well. So I like to call it STEAM. The Arduino is built on open hardware. So that means you can change it. When people know, I always tend to buy the copy ones. I'm not saying you should, but I do. But the Arduino's solid, good support, brilliant company, but it is open source, so you can change it and do what you want to it. So we're just going to watch a little 100 seconds of video now, just like, a promo that's far more professional than my voiceovers. So we'll just watch this little video for 100 seconds before we move on.
Arduino, an open-source programmable circuit board and microcontroller that makes it possible for anyone to build digital hardware products. The idea started in Italy in 2005 and today has sold over 10 million boards worldwide. The most popular model is the Uno, and at its heart we have a microcontroller, which is like a small inexpensive computer that can run on low power. The board is surrounded by pins that can be used to construct a circuit by connecting various input and output devices. Most importantly though, it has a USB port that's used to easily upload your code to the device. In Arduino, a software program is called a sketch, which is written in a purpose-built, easy-to-learn programming language. Every program has two basic functions. Setup runs once when the hardware is first powered on, and loop runs continuously to react to signals from input devices or changes to the state of the program. Arduinos have been used to build IoT products, robots, wearable devices, and all kinds of other crazy hardware ideas. To get started, obtain a board, then download its custom IDE, or use the VS Code plugin if you prefer. Once installed, connect your board via USB, then create a new sketch, which is just a file ending in .ini. The language itself feels like a simplified version of C, with plenty of built-in functions to make hardware coding more accessible. The setup function runs once when the board is reset or powered up. We could use the built-in pin mode function to select a pin, like the built-in LED, and then configure it as an input or output. And now in the loop function, we can turn the LED on by writing to it with a value of high, which is a constant that will increase the voltage to that pin and make it shine. To make it blink, we can follow it with a delay, then switch the voltage to low. And now we can hit the upload button to compile and run this code on the Arduino's microcontroller. Congratulations, you just built a custom hardware product. But there's a lot more we could do here. Connect a breadboard to it to create circuits without the need for soldering. The Arduino can power it by connecting the positive side to the 5-volt pin and the negative side to the ground pin. And now connect components like LEDs, capacitors, resistors, battery packs, motors, and switches to the breadboard. These components then connect back to the digital pins on the Arduino. Once connected, these components can be controlled in your code by referencing the pin number. With a little bit of code, you can make it do anything you can imagine. This has been Arduino in 100 seconds. Hit the like button if you want to see more hardware development content on this channel. Thanks for watching, and I will see you in the next one.
So there you go. So, like I said, a bit more glossy than me. So the Internet of Things is everything connected everywhere. It's a real massive growth, still emerging market. And it is important on our learning journey because what we're learning to do is we're learning to bridge the physical and digital world, so we're actually programming physical things, which is really, really good. And it's really good for empowering us in our innovation and our problem solving. And that's what's needed, definitely in the world that we all live in. So, and at the end of this, there is real high demand career opportunities in this. So the IDE, it's the integrated development environment. So it's similar to the one we was using last week for Python, using Thonny. And that's a sort of a scaled down sort of big IDE, but it's a small IDE. So it shows you if your code's wrong, you get output telling you what your errors are and things like that. So we need to download that from Arduino.cc, which is a fantastic resource. It shows you like the boards you can get. There's projects on there. The documentation is brilliant. There's also a cloud version. So if you log in, you can actually do it from the cloud rather than it just being on your specific device, computer, whatever it is you're writing your code from. But the other absolutely brilliant thing with Arduino is the documentation, in my opinion. So if you click File in your IDE, you've got loads and loads of examples, and that opens the sketch that they call, which is the programming language written for Arduino, but for all intents and purposes, it's C or C++. But in there, when you open your sketch, you've got a little link in there that links back to the Arduino website, the CC, which gives you like the tutorial for that particular example. So this one's a barometer, I think. But yeah, so it's really, really good for that sort of thing. So there's literally like tons of examples. It's a great learning journey, and it's really, really well structured and well documented. So what we're going to do, just to start with, we're going to just make this basic circuit, and we're going to just do like we did last week. We're going to do a blinky LED, but we're going to do it to a breadboard. You don't have to do it to a breadboard, but I just want us to get into the habit of it. And if you can, maybe try and map it in Fritzing first, so you've got something that you can keep. So we need to connect our Arduino board to the computer, open the IDE. Then we need to make sure from the menu options at the top, we go to Tools, we select the correct board. If the board's showing up, sometimes the board doesn't show up, so we need to make sure that we've connected the correct port. So on that same one on Tools, you go to Port, and you'll see on USB that the port will be like TTY, but it often says things like USB, or if the device is connected, it will say the device as well. A little mention, little sort of caveat is that sometimes when I've done this, if I've done this with like cheaper USB wires and things like that, sometimes it's the wire that stops it for working. So this one, we're going to use the blink example. So you can either type in what's there, or you can actually just open the blink example. Then you will click tick, and that checks your syntax, and then it will compile. If you press the arrow pointing to the right, that will then compile and upload that software to the Arduino. There's a myriad of resources out there, an absolute myriad of resources. Arduinos, there's like literally 12-hour videos on YouTube and things like that, full Arduino courses. There's people's projects left, right, and center. I absolutely love Redno or Shanghongshu. It's absolutely fantastic for Arduino projects and little electronics projects. But the best resource of all is just experimenting and just innovating and just trying to do things. I mean, what's the worst that can happen? So the most important takeaway that everyone has to remember from this session and these last two sessions, this is going to lead into next week, is that, everything's created by somebody. Everything's a thought in somebody's mind. Everything's an idea. Mark Zuckerberg liked a program called Friendster, and he liked AOL Messenger, and he liked MySpace, so he put it all together and made Facebook. It's just an idea. That's all these things are, but it's us that have the ideas. People are saying AI, this, that, and the other. AI is assistive. The ideas actually come from you. So it's about innovating and just making continuous improvements and integrating them improvements into what it is that you're doing. And that's the way that we'll move forward. So what will I do next? So that's the one. So we've got 2 weeks left on this. So what I'm going to say for next week is this is where we need to start making our little project that's going to be your project for the last 2 weeks that you can then document. And if you're doing it on an Arduino, I've said, you can take your project. Once you've completed it, your project can go with you. You can have that. If you're going to do it on a Raspberry Pi, I can only let you have a Raspberry Pi 3. My Raspberry Pi 4s and 5s are still in quite high demand. But you can, if you do a project on a Raspberry Pi, on a Raspberry Pi 3, same again, you can take that away with you. But make sure you document it. Make sure you've got a record of what you've done. And we are going to have other stuff coming forward with this. Hopefully like a little makerspace going on at the Middleton Lighthouse Project. But start thinking about and start having a bit of an examine on the internet. Just what sort of projects you'd like to do and the ideas you might have that we can explore. So look forward to seeing you all next week. Thanks a lot.